Ground faults are unwanted paths to earth in electrical systems. They are often due to damaged wires, faulty insulation, as well as dust and dirt. Ground faults can present hazards to personnel and equipment. A low resistance fault can lead to high current flows that can cause equipment to trip offline or even fail. A high impedance fault can lead to high differences of potential, leading to shock hazards. Ground faults have led to safety issues such as fires as well as shocking of personnel. This is why it's important to locate these faults quickly. In some regions, such as North America, it is a NERC requirement that ground faults must be located. Some common causes of ground faults include pinched wires, often due to maintenance errors. Damaged wires can often be contributed to rodents or pest damage. Ground faults are often due to faulty insulation. This is often caused by water ingress into the wire, creating a path to earth. It is common to see more ground faults after a severe storm due to the moisture associated with that storm. Now, as these severe weather events become more common, so will ground faults. Ungrounded DC systems, or IT-grounded AC systems, are designed in such a way that a single ground fault will not trip offline vital equipment. However, should a second ground fault occur in the same circuit, this can lead to extremely high levels of current flows that can lead to catastrophic failures. This is why these types of circuits have ground fault monitors. They inform the operator when a ground fault occurs. However, they will not tell the operator where the ground fault is. The basics of ground fault tracing is simple. A transmitter applies a signal that flows through the ground fault, and that signal is traced using a receiver. However, nothing is as easy as it seems. There are many things that can cause problems and keep an operator from locating a ground fault. These can include high leakage current due to high capacitance in the circuit noise, a high impedance fault, plus there is always the danger of tripping a breaker. All cables have some level of capacitance. Capacitance looks like a false ground path to a ground fault tracer. The longer the cable runs, the higher the capacitance, the bigger the problem. High circuit capacitance could cause an operator to trace the wrong path all day and never find the fault. The MGFL100 allows the operator to measure both the real current and the reactive current drawn by the stray capacitance. So this way you'll never trace the wrong path again. Noise on a circuit, such as from a SCADA system, can swamp out the trace signal, making it impossible to locate a fault. The MGFL100 transmitter outputs a low-frequency signal, 5.12 Hz. The receiver has a low-pass filter that measures this low-frequency signal. This is well below the noise level on the circuits being traced. When cables sit in water, their insulation breaks down over time. This leads to high impedance faults. The problem with trying to locate them is you need to generate enough current to be able to trace the signal. However, the more current you use, the more heat you generate. This will dry out the fault before you find it. The MGFL100 will trace faults up to 400 k-ohms using minimal energy. Others require hazardous voltages up to 1,000 volts to trace these levels of faults. These high voltages can be hazardous to the operator and they could trip breakers. Plus, these high voltages can drive too much current, thus drying out the fault before it's located. If a breaker is tripped, then a critical system goes offline. This is exactly what you do not want to happen. This will occur when a breaker is close to tripping and the operator searching for the fault uses too high of a current to trace the fault. The MGFL100 allows the operator to put in password-protected limits on both the maximum voltage output and/or the maximum current output. The password protection assures the limits are not accidentally changed. The basic operation of the MGFL100 is simple. Connect the transmitter's 3 output leads, 2 across the battery string and 1 to earth. Power up the transmitter. The transmitter can be powered off of an AC outlet or off its own internal batteries. Once powered up, the transmitter will indicate which side of the string has the fault. Energize the side with the fault and turn up the voltage output to about 10 volts or 50 milliamps. The transmitter will now indicate the impedance and capacitance of the circuit. You can now see the value of the fault. Connect the receiver to the transmitter's output. The receiver now shows you how much current the real fault is drawing and how much current is being drawn by stray leakage capacitance. You can then set the limit trigger, and this will allow the receiver to automatically find the circuit with the real fault. Move the CT to each circuit on the panel. The receiver will provide a visual indication as well as an audible tone when you're on the circuit with the real fault. Once you know the circuit with the fault, you can proceed with tracing. Finding the circuit with the real fault is only part of the task. You now need to locate the fault. This can pose some challenges as well. During tracing, a fault can split amongst multiple paths. Which ones do you trace? Which ones are real and which are due to stray leakage capacitance? The MGFL100's patented capacitor pickup will allow you to determine which circuit has the real fault. This way you do not waste time tracing false paths. Fault tracing can lead you into tight areas where probes do not easily fit. The MGFL100's active mini-CT utilizes a high-sensitivity flux gate technology. This allows it to use a small core, which keeps its overall size small. The probe also incorporates a sliding opening, which allows it to fit into very tight locations. Now, during tracing, it is assumed that any DC current on the lines is minimal. However, it is possible that a CT can be placed around a wire that has DC current flowing through it. After all, a battery string is a DC system. When a current clamp is placed around a wire with DC current flowing through it, the CT's iron core will become magnetized. It will make it difficult or even impossible to take that CT off. Many times the CT will be damaged or broken in the attempt. The MGFL100's I-clamp CT uses a mu-metal core. This means it will not magnetize when placed on lines with high levels of DC current. Ground faults can occur on both DC and AC circuits. In TT-grounded AC circuits, a breaker will trip in the presence of a fault. However, in critical circuits, an IT ground will be used. This will ensure critical equipment does not trip offline in the presence of a single ground fault. The MGFL100's IT filter allows you to locate ground faults on these IT-grounded systems. Simply place the filter between the transmitter and the circuit. You can now trace AC ground faults on circuits up to 600 volts. The MGFL100's receiver can also be placed in a 50 or 60 Hz mode. In this mode, the receiver can be used to trace fundamental currents on any type of AC circuit. There are also straps available for the receiver. These allow the receiver to be hung from metal surfaces using magnets or hung using a clip. This allows for hands-free operation. A standalone battery charger is also available. Now, fault tracing is not done every day. The transmitter could be sitting on a shelf for long periods of time. The standalone charger allows you to keep a spare set of batteries always fully charged. This way you do not have to use the internal charger in the transmitter, and you can keep the transmitter out of the way safely in storage. This way you will always have fully charged batteries when you need them. The MGFL100 is a versatile, simple-to-use tool for locating ground faults on both DC and AC systems. Powered off AC or battery. Never be limited by either a lack of an AC outlet or uncharged batteries. Direct measurement of capacitance and resistance. Never waste time tracing false paths again. Alarms indicate when the fault is found. The instrument tells you when you're on the line with the real fault. Programmable limits. Program the unit with your maximum voltage and current limits. Never trip a breaker again. Detects faults up to 400 k-ohm on systems up to 600 volts. Locate both low impedance faults and high impedance faults due to water regress on both AC and DC systems. The MGFL100, it is the only fault tracer you will ever need.